Welcome back to the stream. I've been working on so much CAD, trying to get these robots built, and a lot of it feels, I don't know, like stuff that I probably wouldn't be super enthusiastic about sharing because I feel kind of bored even just doing it myself, but then I'm getting to the end where it might actually start being kind of interesting. It's coming together, and I've got a big pile full of parts off the printer. It's most of those parts, well, of the stuff that I've got designed, and if you exclude the stuff that I just finished designing like yesterday, I've got pretty much everything printed for 4 Winch bots and the flyer robot. So this project's coming along. I've been trying to kind of race and get all the CAD done because I feel like the kind of limiting factor for at least this part of the project is going to be how quickly I can get started printing some of the larger pieces that'll take a while to print. And I figure, I want to get those started as soon as possible, but then while those are printing, I can work on software and some other stuff. But so far, I've been keeping the printer busy, but it's also taken a long time to get the CAD actually finalized for this, so it's at this point I've got most of the structural parts actually printed for this. The stuff that I just finished designing are these brackets that hold the electronics. So those are over here on this table. And my tea. It's not the best place for the tea, but it's the one I had. So there's the winch so far. As seen on some earlier streams, lifting, well, I showed it lifting 2.5 kilograms just fine, which is about all I felt like putting on it. I didn't really want to destructively test this, and the load cell is only rated for 5 kilograms, so keeping in mind that that should be a dynamic load limit, I didn't want to really put too heavy a static load on it. And 1.5 kilograms is about what this should have to lift, about worst case, for the actual robot that I'm building. So this thing is tested and pretty much working. And these boards trailing off of it are the electronics that are also tested and working and just needed a place to live. So we've got a motor driver. This is a very over-spec'd H-bridge that's rated at something like 46 amps. That was kind of the next cheap step up that I found after blowing out the smaller H-bridges that I'd been using. I should probably record some of this, although I don't know how much of this I'm actually going to edit together. Have a little bit of footage pointed in this direction might be good. So big capacitor here is basically to reduce the amount of overvoltage we get during normal deceleration operations. So if there's an extreme deceleration, we end up with a lot of load dump, then it'll keep that from rising especially sharply. And when it does rise above, I think, 26 volts or so, 27 volts, then we'll start getting into the overvoltage cutoff, and the power supply will just cut off power to the system for a few seconds, which seems like an alright mode in that case, because if we get to that point, it means the firmware messed something up in the first place. If that turns out to be wrong and we end up needing to dump energy more often than I expect we will, then I might think about adding some kind of active load dump. But at the moment, the limiting factor in acceleration is how fast we can move the camera without it swinging. So in general, we'll be accelerating and decelerating fairly slowly, and I won't expect that to be a problem worthy of cutting an entirely other circuit board to solve. Since so far, this is actually just made out of kind of jelly bean off-the-shelf stuff with very minimal modification. So here behind the T is the microcontroller. This is a TI Launchpad development board that basically houses a processor that on its own is like $16 in single quantities, but this whole board is like 20 bucks. And it's a microcontroller with a lot of good on-chip peripherals, on-chip 100 base T Ethernet, which was super useful for this. And so it's good at motor controls. It has a built-in quadrature decoder, which can read the signals from the this encoder wheel in hardware. So that's all nice. And then an unexpectedly beefy power supply over there in the corner. I was originally hoping to run this off of a 2.5 amp 24 volt brick, which was a kind of a convenient size to get, at least. There's kind of a big step up when you wanted something bigger than that, and so then this is what I ended up with, which is rated for 6.5 amps and is much bigger and is not enclosed. But it seems like it would be useful anyway when you're getting up into these kinds of currents to keep the power supply close to the load anyway, so that you reduce the amount of wiring that you have to worry about short circuits across and that sort of thing. So having the power supply in the enclosure with the whole winch seemed to make sense for a few reasons. And so I've been designing this system for mounting basically all of this stuff right under the motor. So this bracket, you can see right here, I've already got one of the motor controller H-bridges in here. It's fitting into a slot on the bottom, and then there's posts for threaded inserts on the top to keep the board in. This is the power inlet on here with all these reinforcements so that it can handle the power cord going in and out without having any flex or anything like that. And then this plate here is just for insulation so that I can have an extra layer of protection between the high voltage wiring here and it'll be right up against the end of the motor drive capacitor over here. And then this, I didn't really have room for a better, like a fully enclosed place for the capacitor to hang out. And I was afraid of kind of putting pressure on the capacitor with zip ties, and I also didn't really have that much room. So I decided that I would just leave room to attach it with like silicone, like Celastic stuff. And I added this cutout here to give the glue a little more space to hang on to. So capacitor sits in there with a little bit of RTV silicone on top of it. And then some wiring, motor attaches to the motor driver. And then this is another housing over here for this that little e-stop switch. Actually, Big Clive took apart one of the same switches in that series. It's one of the ones you can get really cheap off of eBay, but they're actually, surprisingly well made inside. And I wouldn't trust them for like industrial machinery, but for something like this where you basically just need a chunky on-off switch with a pretty good mechanical latching action, it seemed like a pretty decent choice. It seems to have decent contacts and contact wiping action and all that. So for that, I added a little bit of additional insulation with this box that the switch hangs out in. And the bottom of this sits up against another plastic piece. And the switch has terminals on the bottom side and on the top side, but I'd be orienting it so that I don't use the bottom side terminals, just the top side ones. And then the wiring would be insulated right in this corner and in the corresponding corner on the other half of this. And then the wires head out through these holes. So trying to give the high voltage wiring enough, like as much additional insulation in the design of the plastic as I can easily. So I think that's most of the features on this side. These cutouts are for a zip tie to hold some of the wires down. I don't know if that'll end up being super effective, but it was easy to add. This is another screw for holding down the power supply mount. So that's what I've got printed. There's a lot more than this that I just finished designing like yesterday, and so I can show you that in CAD. So this is mostly designed at this point. All the stuff that's actually really necessary is designed. At least all the stuff that's necessary to just run this winch. So the piece that's really missing at this point is the shell that goes over it and provides kind of the final layer of protection against fingers poking into the high voltage and moving parts. Let's go back to the desk here. Thanks, camera. You're done for the moment. The other, excuse me, the other half of that piece is still 3D printing. That's the one on the printer right now. Camera in the printer room is currently out of order. I'm working on a replacement situation, but right now I just don't have a camera in the moment, so I could rush over there with a wireless camera, but it doesn't seem especially useful right now. So yeah, another thing I should mention is if you're tuning in now and haven't heard of this project or just want like a recap on what's happened so far, I made a page on hackaday.io for this project, so if you search there for Tuco Flyer, then you can see what's up here. Basically, we're making a camera robot that is going to be interactively hanging out with my awesome cat here in the shop. So it's got some pictures. Here's the gearing assembly for the winch bots that we've been working on. That's the camera on the gimbal. That required some mechanical and firmware modifications to get that working. So kind of an introduction video over here, and a couple of episodes so far on the gimbal modifications. Yeah, I really need to edit some of the winch stuff into a video. The winch project, I haven't really been sure where to like cut it into winch part 1 or something, because that didn't really seem like there was an obvious boundary. So at this point, since it's already pretty much it's already almost done, it might just be worth like collecting all the kind of winch related footage and then telling the story of how the winches work, and that might make a more compelling video than having a bunch of half-baked episodes. So yeah, and that's new. I tried posting one of the live streams here too, but since this is a new page, it's only got one of those so far. Oops. I think we were done with that anyway. All right, so here's the design so far. Can we get some more screen space? That seems fine. All right, so this is everything that's finished turned on. So, just for reference, let me turn off the stuff that isn't in the model yet. So, basically if I turn off all of that, and, well, I guess not this. So this is the stuff that I have. We've been testing it with this top section so far. So these two pieces I've been calling the frame. This is the top bracket. These are the bottom brackets. I know, super imaginative names. These are the PSU arms and the PSU ring. So I've got these parts in the queue to print. This top part is tested. This bottom part is just starting to be tested. So far I've been able to test fit, for example, like the IEC power inlet and motor driver. They're a snug fit, but totally usable. And at least got kind of an idea of what half of this holds, or how half of this holds the button. But yeah, I'll know more once the other half of this prints. So this half, okay, so this is what we were just looking at. So this should match what I was trying to explain in real life, where we've got the power inlet, a place for the capacitor, a slot to help the Celastic hold the capacitor, some slots for the motor driver on the bottom, then posts with a place for threaded inserts on the top. This cutout is just to help get some airflow to the heatsink. This is a place for a nut to go where the side panel is going to mount. So, and then you see we've got a place for these arms that hold the power supply. So that has a nut on this side, long bolt in this side, and then right here, let's turn the power supply back on. So it's this big old 24 volt, 6.5 amp Meanwell thing. And here I happen to have a way to line it up so that we could land this bracket down here to something structurally relevant, and then also bolt it to the power supply. So the way I tried to design this is that these rings fully enclose the supply, and so you could just kind of slide this into these rings and then bolt it on. And that's how you'll put these onto the power supply. The intended assembly order here is that you'd put the rings on the power supply, wire the power supply to the wiring with just a little bit of extra slack in the wiring. So this power supply would be like over here somewhere. And then after everything's wired, then you would put these brackets into place and attach this screw, the corresponding screw on that side, and then these two long screws. And that's all because I just couldn't come up with a good way to allow access to these wiring screws with the whole thing assembled. I mean, the obvious thing to do is just to flip the power supply upside down, but that makes, I mean, I didn't do like a proper thermal analysis on this because I don't have any software to do that kind of expensive thing, but my intuition is that that would make the thermal properties of this significantly worse. Right now, the intended airflow here is that you get air mostly coming in through this side vent and then passing across all of these power supply components. There's a big heat sink on the back, there's some heat sinks in the middle, absorbing a little bit of heat. None of these components are going to get that hot, so I'm not worried about the plastic or anything. But, you know, in order to ensure that they don't get that hot, you need to think about the airflow at least a little bit. So what I'm hoping happens here is that air kind of comes in through this vent, passes across the heat sinks, and gets drawn upwards by the air currents. And then there's actually a decent amount of kind of cutouts and stuff in here, but I mean, not nearly as much as I'd like, but I kind of did what I could to keep this relatively open. So the air can kind of flow up around the motor, and some of it might kind of go back across here and out through the back. I did leave these vent holes so that some of the air right from around the motor can flow up through this open space, and then potentially get entrained in moving air from this mechanism. If I'd thought of this earlier, I would have even added little fins to the spool to try to push the air around as it moves, but I didn't, and it wasn't really worth redesigning this. And then, so there's a big open space for the air to flow through, and then I would want to be sure that that I've kind of vent holes along the outer shell, probably some right here because the air is going to pool up against this surface, and then some at the top. And then maybe also just some openings so that you can see the mechanism in here, because that might be cool, as long as I can do it without a safety hazard. So that's pretty much the next thing to design, is the outer shell. Obviously a really large piece, and in order to keep it from being just a ridiculously huge print, I would want it to be pretty thin. So I was thinking maybe 1mm would be a good place to start, since that's something that seems like it would be self-supporting enough, but would not seem overly thick. And the outer shell here does not need to be at all structural. I designed this so that I'm not relying on it for, you know, even for this button. So the shell is going to be basically avoiding the area right around this button, and all of the force from pressing it, when you do press it, all of that gets transmitted through this frame back to structurally important members. So like, this is anchored to the rest of the frame through 6 bolts right around the motor. I think I have to turn off the power supply to see those. So yeah, these 6 M3 bolts hold the 2 brackets here in aggregate. So you can kind of think of these two as one piece once they bolt together, because they get bolted together quite sturdy. So they'll be held by this screw, that screw, this screw, and indirectly through the power supply bracket once this is installed. So this whole thing should form a pretty rigid ring. And then that whole thing itself is held together somewhat less well than I would like, but as well as the geometry of the stuff I had already designed would allow. That's all held together to the frame by these 6 bolts. So obviously some places where, like, if I was just doing another revision of this entire design, like, it might be nice to have a way for this bolt to pass all the way through. Well, that couldn't pass all the way through, but like, to at least have some more anchoring points between this bracket and the frame, because this is one of the areas I'm less confident about, but I think this is going to be fine. Whereas all of this stuff, you know, this is fairly beefy and structural. Like, this has to carry the load of this cord tension around and keep these axles aligned and all that. So like, this involves a lot of structural doings. This stuff is mostly just, it just has to not fall, basically. I mean, it has to hold the weight of this power supply. Honestly, the thing that I was worried the most about was keeping it from feeling too flimsy as you're inserting and removing cables and interacting with this button. So that's one reason for kind of all this reinforcement around the mounts for that stuff. So like this thick area right here is all to keep this thing from feeling flimsy around the Ethernet cable entry. So that's pretty much that. There's the microcontroller board. I also tried to keep it so that without the outer shell installed, you can easily just plug a USB cable in here for in-circuit programming. This thing totally seems like kind of a skull or something. Like this is its nose and these are its teeth. I also started referring to this as a spool pig, because I thought it kind of looked like a pig, especially if you turn off the... If I turn off these power supply mounting brackets... PSU arms, yeah, this and this. So if you turn those off, well, I guess now it's a two-legged pig, but before I changed the way the power supply mount worked, I had 4 screws in here, and so it looked like the screws were little tiny legs, and then this was like a really big body or something, and then like a giant like snout, and then a springy tail, and it has a big spool in its body, so clearly it's a spool pig. Anyway, that's how my imagination works sometimes. So those pieces are really mostly involved in keeping the electronics together, providing a housing for this button, providing some more insulation for the high voltage stuff. So the high voltage path here is really simple. Power comes in through here. I tried to leave enough room to solder or rework these connections, but not so much so that it was really a danger of shorting out to anything. Obviously, ideally, you would just do these connections before putting this in, but I wanted to make sure that that wasn't necessary, so I tried to leave room to do it the other way around too. And then, so that can just go directly to some insulated cable, which then runs to the power supply, and the hot line there, so this will be hot, neutral, and ground. So neutral and ground can go directly to the power supply, and the hot line will get routed through this box, so it'll go in one side and out the other, and then to the screw terminal. So that seems pretty straightforward. This will be a little bit strange to assemble. So the order of operations is a little bit specific. So you have to assemble, well, I'm assuming that you already have this part of the frame assembled because it already is in my case. The motor is not really possible to separate from this frame non-destructively because this little gear press fits onto the motor with a hammer, and to get it off, you might be able to get it off with some tool that you could build that I don't have, but the easy way to get it off is destructively, and so ideally I would not want to have to do that. Could reprint that piece, but it's annoying. So this is already assembled, but it's still possible to slip some nuts into these slots and then assemble 1/2 of this blue bracket at a time onto this frame. So I can actually already demonstrate how that works on this camera. Also, T is such a thing. Yeah, it's nice when the designs end up being, I mean, it's one of those things that I appreciate is when you put a lot of time into a design and it's acted on by all of these constraints, then there's a certain beauty that comes out of that sometimes. It's nice to observe that and to create it when you can. Stack up all this hardware so that I can carry it around. Yeah, I was really looking forward to having a bracket to mount all this electronics on. So here's what we've got so far. So the top side of this is pretty much done. So the overall structure of this thing, just for a bit of a recap on this. So this blue piece is the frame as seen in CAD, and its job is basically to hold these axles and to transmit all the forces involved in keeping the axles in place. So there's a big axle clearly for the spool. There's also this axle, which isn't under quite as much force, but does have to be fairly sturdy too. Then these rollers, and these luckily are designed so that they're pretty much just under compression, so that you're using the grain of the 3D print the way it's strong, so you're kind of pressing these layers together and then against this whole middle section. So then this top section, another name for this is the measurement assembly, because it's really involved in giving the microcontroller some feedback about the force and the distance traveled. So I've got this optical encoder with a wheel. This is all designed such that this roller presses the cord down so that it stays on this flat roller, and then this roller presses it up against this capstan so that when there's tension on this whole cord, if I simulate that by just pulling on this a little bit. When there's tension on this, then there's a smaller but proportional amount of tension in this whole, in this section of the cord pressing against this capstan. So you can hear the friction if I spin that while I'm pulling on there, but not if I'm not pulling. So that's the function of this roller. And that's just designed because, you know, I didn't want the entire force of that on the encoder because I wanted to be pretty gentle with it. I just wanted just enough to keep the friction. And just to increase the ratio of friction to, you know, to increase the coefficient of friction, basically, the ratio of how much friction force I get to how much force there is perpendicular to the axle here. That's what these ridges are for. I tried to make them still close enough together that they wouldn't affect the measurement in a way that was relevant to my interests. And then this final thing, of course, is the load cell. So this is what measures the actual force. This end is anchored, this end has a pulley on it, this middle part flexes ever so slightly, and some tiny resistors change just a little bit. And the tiny change in resistance is amplified by this HX711 breakout. So that's what I got so far. Then, which side does this go on? All right, so these wires from the sensors have to go to the left. I want to keep the motor out of the way too, and also the paracord, but I'm not actually fitting this, so this isn't quite as important. So then, oh yeah, almost like it was designed that way. Yeah, so that fits right around the piece we've got. I think that'll be fine. And so there's enough room for these wires to hang out below the switch and just go right over here and then through another channel to where the microcontroller is. This will just come right out and go over here. And then you can see the places to get these two halves anchored to each other. I will want to put a little bit of Loctite on these nuts before putting this in, I think. And yeah. When I was testing this, none of these parts really got that warm. Like the motor driver just stayed cold, the power supply stayed cold. I mean, I'm giving them airflow so that they do stay cold, but in free air on my desk, none of these things seem to even start to be problems. I was getting a little bit of warmth from the motor, and so that's the area that I'm most concerned about, especially since it's just like buried in the middle of this whole contraption. But just given the overall duty cycle on these things, like they're not going to be racing around the room all the time. They'll be positioning a camera, so I don't think heat buildup is going to be a giant concern in my application, but it's just one of those things in the design that I'd like to avoid that being a problem if I can. So that's why my concession was to add these holes so that it wouldn't be, you know, if it was just completely enclosed, then that's a great way to have a little oven that just cooks my motor and melts all the plastic. But having some way for the warmest air to escape seems like it'll keep that under control. But yeah, that seems like it's fitting pretty nicely. The other part on the printer is, I think, like 80% done, so. Oh, and I don't know if I've explained this back part yet. So as far as anchoring this whole thing to something structural, so in my case, well, I don't know exactly where I'm going to be attaching this. It looks like on one side of the room, well, I don't know, I don't need to go into like my own like interior design motivations at the moment, but basically the walls here are super strange, and I thought I would design something basically so that I can attach this to a standard 2x4 piece of lumber and then attach that via whatever means I want. So, and so in some cases, maybe I'm attaching, you know, I wanted it to be versatile such that you could attach this directly to a wall stud. But I thought that mostly the way I would want to use this is to have this attach to kind of a swiveling mount that would let you position this at the right angle. And then that swiveling mount would be sized to attach to a 2x4 running vertically. And then that 2x4 would then give you kind of a long lever arm to clamp or bolt onto something else. Because, you know, if you want, like the torques involved in just kind of like anchoring this thing to the wall in a small area can be enough that I think I wouldn't really be able to do that super reliably. You know, either I'd have to use so much force that it would damage what I'm attaching it to, or it would just like work itself loose. So, you know, to provide some more flexibility in mounting options, I thought I would just design this to attach to something kind of malleable like wood. So I've got this other piece that's designed to basically fit right up against here. And so it's designed to basically hang from this bolt, but then I'm also tightening a nut against this, so kind of cinching this under tension. So as you can imagine, that by itself will actually hang this reasonably well. And so this is kind of acting as a lever where, like, my pinky here is the fulcrum, and then I'm pulling the weight of this against this fulcrum through this big ol' M8 bolt. So that's how it would operate when this is idle and it's just like holding its own weight. But actually most of the time, the tension on this cable will actually offset the entire weight of the winch, and I'll need to hold it down. So that's what this whole assembly is for. So this will fit up against kind of a finger like that in the wall mount bracket and prevent this whole thing from coming up out of the wall. So at least that's the plan. I hope that part works. You can take a look at the things that are designed but not printed back in CAD. This thing gets so big, and I have 4 of them. There are going to be 4 of these. It's just so much winch. Also, I miss Tuco. I think Tuco must be hanging out upstairs. I've got that camera just on the pile of 3D printed parts right now. Okay, so this is what we've been looking at. Well, plus the couple of next parts that I'm printing. So I've also got, here's that 2x4 that I was just talking about, and this mounting plate. So let's look at just the mounting plate. So, tried to minimize the plastic in this such that it's like a 10-hour print instead of like a 30-hour print. So we can get, well, I also was really concerned about using the layers of plastic in their strong axis. So that's why you can see I'm using these really long screws. These are going to be like 3-inch wood screws, I think. Some of that might be a little bit long if I end up using like these screw holes, but so these will hold down from the very top layer, and they'll kind of compress all these layers up against the 2x4. And so you can imagine kind of loops of plastic grabbing both the shaft of these screws and providing an edge for this interface to grab up against. And so that'll be using the plastic in the strongest way I can. And this is also pretty thick. I think this is like 10 millimeters. 11, so yeah. And then these sections here don't have to be super load bearing. This is mostly just so that the bracket keeps its shape even if the wood is a little bit warped. This could even just be 2 separate pieces, for example, if you didn't, you know, if you could just align these completely perfectly, but it's more convenient to have it be 1 piece. And then over here, I've got something similar where I'm holding down loops of plastic on these edges and then relying on the strength of this middle section. So this is holding the back of this nut cover assembly. So this whole section here, culminating in this face right here under the mouse, yeah, that one. So that's actually holding this whole thing up against the wall, kind of backed by all the plastic up here. You've also got these little edges that are coming out here. And that's actually also kind of important. That keeps this whole assembly from riding up once the nut's been tightened, but when the nut's loose, you can still get the whole thing up. So the way you can take this off the wall is by loosening this nut as much as you can, and then you can just raise the robot up off the wall mount bracket and pull it off. So that's the other reason for this bracket, is so that you can just attach this bracket via whatever means are convenient. Like, you could even just modify this bracket to, like, for example, I actually have metal beams on a couple of sides of the room, such that it might be really nice to attach a bracket using C-clamps. So maybe there's some other way that I could modify this bracket for that purpose. I think my so far I just figured it was much easier and probably more foolproof to design something that attaches reliably to the wood, and then just have a sacrificial piece of wood I can let the C-clamps dig into. And so this seemed like a pretty good solution to that problem also, at least in my use case. So let's go back up to the top level project here. Okay, so this is like the minimum viable winch bot. You could just build this and it would work. And it would have a little bit of exposed high voltage and a lot of exposed moving parts. And I would not want to run this around children or small animals, but it would work in a laboratory environment for sure. For making this a little bit more home-friendly, that's where the shell comes in and just covers all the high voltage and all the moving parts and keeps my cat and my visitors safe especially. So that's designed to mount via these 4 holes on this side, and correspondingly these 4 holes on this side. And I just want it to stay out of the way of all the moving parts. And it can also stay out of the way of all the stuff that has to be like externally accessible. So this IEC power inlet over here, you can see I've been really lazy about modeling it. I just made a bare minimum model for it. Likewise, this over here is supposed to be an RJ45 network jack. But yeah, that'll look nicer once I actually have a circuit board in there. So my plan there is just to leave this section of the case open, provide maybe a nice edge for it if I can, but mostly the case is going to be a thin kind of millimeter shell around this whole section. So let's try to get our bearings. I'll try not to make everyone seasick with my navigation here. Oh yeah, before I go too far into the new design, the section views are also kind of fun. I really like getting a sense of how everything actually mounts using the section view. This is pretty close to the middle right now. Also, if you leave the camera still for a sec, it'll calculate all the edges. Look a little nicer. Let's get a little more screen space for that. So this makes it much clearer, for example, like what path the force is taking to get from the wall mount bracket all the way to the end of this lever, for example. So you can see like this is attached there, then this is attached to this whole frame, which has some plastic there, then a lot more kind of around here too. And then you can see it attaching back here with this point here and this interface down there. Maybe this is easier. Sure is a lot of stuff in this design. The motor is not actually solid, it's just modeled that way. Yeah, this is good for getting a sense of how this interface works. I mean, this is kind of the same view that you get in the slicer when you're preparing the 3D model. But this is, since I'm slicing the model in the same axis that the, oh, Windows Update, this is not the right time. Yeah, since I'm slicing the model in the same axis that the 3D printer slicer is working in, I get to see, okay, these are the actual loops of plastic that are going to be providing strength for me. You can see this cutout, actually. This would normally be a big problem for strength. I had to add this cutout so the wires can get from this channel to the microcontroller board. But it ends right about there, and then I reinforce it with a bunch more plastic, so I think it'll be fine. You can also see the gears in some nice detail. Anyway. Okay, so this end is up. So I've started working on the shell. Let's turn that on. So it looks really boxy. I don't want it to look this boxy. And I think part of the problem is, so I started by defining a profile in this axis and then kind of cutting out some parts. And I think I actually need to sculpt it a bit more in this plane. So I'm going to backtrack just a little bit. Gotta scroll all the way to the end of this history list. Oh, actually, let's isolate just the shell. That'll make this a little bit easier. Okay, so here's where I made it hollow, and I want to put that off and do some more modifications before making it hollow. So let's go back before that. Oh, this is also part of why I have not been streaming CAD much lately, is this program has been getting slow. I mean, I don't have to have all of these things on. That would probably help right now. But for some of this, I kind of do, because I'm trying to design this so that I can actually have an enclosure that fits all my parts. But for right now, let's turn most of this off. That might be faster. Okay, so it's not shelled. I also want to get rid of this chamfer, which was right there. Alright, so there's my boxy thing. So, how did we get here? So, I made a plane in the middle. I made this sketch on that plane that defines this outer shape without any of the roundedness to it. I was kind of torn between getting the round corners with fillets afterwards, like I've done here, and trying to do it in the sketch. I'm already just wanting to turn all these things back on, though, so I can start to see the stuff that's in my design. This also gets really busy because I start to want hidden lines. So, I mean, you can kind of see the results of this approach. These thick lines are the sketch, and I drew just a box and then rounded it afterwards as much as I could stand to. But let's think about this axis a bit. So you can see that it looks a little different in this axis. It needs to be wide throughout most of this, but I can kind of take off these bottom corners. And up here, it can come in quite a bit. And maybe the way to do this is just to make another sketch and like intersect and chop off these corners and those corners. I mean, that seems fine. I don't really see a reason to backtrack any of that work. It's kind of, I mean, it's not elegant, but... I mean, the thing is, I'm not as interested in having a shape that's super form-fitting as I am in having a shape that kind of visually makes sense and doesn't look too bulky, if that makes sense. And as far as actually optimizing the material that I'm using, mostly what matters is keeping this profile fairly compact. And I've done that, as you might have guessed, through designing, like through placing the components more than anything else. Because like this view right here is pretty much why the design is the shape it is I wanted to kind of keep this whole thing relatively compact. So, you know, so like this is a separate piece, but this whole shell fits on my 3D printer. Like, how wide is it from this edge to this edge? 273 millimeters, and my 3D printer is 305 millimeters. So, plenty of room to spare, right? And there are plenty of ways to make this that are not 3D printing. It's just, despite the existence of all those ways, 3D printing is still probably the most convenient way for me to make this specific shape. And if I design it to be thin and to have supports in the right places, then it doesn't need to be a really long print job. But one thing that does mean is that I have to pick an axis to be, or I have to pick a plane to be against the print bed. And so the obvious choice is cut it in half, print here, then on the other side. Wow, that sure gets slow once the hidden lines load. And then another side, print it here. And part of what that means is that when I do cuts looking at it along this plane, I have to think about printability, because for example, if I just took out a rectangle here, now all of that is on top of support material, and it doesn't really help me that much. If I cut it at an angle, maybe that helps, but if the angle is too steep, now I have overhangs I can't print. So I think the ideal thing here is to have an angle here that's just the steepest overhang I can confidently print with my printer, and to do that on both sides. And it would be nice to just avoid having to use support material, because it's going to be a big print anyway. Having support material around the entire perimeter of such a large object is going to be a non-trivial proportion of the object's plastic. And I can avoid it just by changing the angle that I bevel the corners at, so why wouldn't I? It's one of those cases where, like, there isn't necessarily a specific aesthetic I'm going for here. I just want it to be compact and to have some kind of aesthetic consistency. So I can let the engineering decisions drive that to a large extent. And then so these, okay, so why did I choose these specific sides and then the angles involved? So when I made that sketch, I actually chose reference points like the back of this power supply and the bottom of these brackets, and the front of these brackets, and I picked a distance, like I think 6 millimeters or something. Enough to have maybe a 4 millimeter margin for things to wobble around and for them to not still have any danger of hitting the shell, and then a couple of millimeters for plastic thickness where I want it, with the expectation that most of the plastic would be maybe just 1 millimeter thick. Actually, what did I do in that sketch? Maybe let's look back at that. Oh, sorry, I've been behind on chat. Oh, nice. I would totally take CAD pictures if anybody has them. It's usually the case. Oh, good question from Jarrett, if there will be provision for sound insulation if you need it. Quite possibly. I mean, that is something I could design. How would I do that? I'd probably want to leave room for vibration dampening washers. Do I have room for that? I could have room for that. I wonder how hard it would be to print the entire enclosure to semiflex. That would be a slow print, though. Semiflex prints slowly. I guess I could print it in Cheetah. That's kind of their deal, right? But yeah, that's a good question. Yeah, as for sound insulation, So I don't know how much I'm going to have to worry about conducted vibrations into the shell. That's something where, if that's a problem, then I might have to... See, I guess the reason I'm worrying about the spacer is the presence or absence of a washer like that would change the... it just changes the size of the mounting posts a little bit. You know, another thing I could do, honestly, is to have the two halves of the shell bolt to each other, and then to have a like a semi-flexible insert that has little pegs that fit into the screw holes on the frame. Like, there's a bunch of vibration isolation strategies. I guess basically I don't know how much that's going to be necessary, and I don't want to over-design it too much before I get into that, because like so far I've been fairly underwhelmed by the amount of noise this thing has produced, so sound insulation hasn't been a huge priority for me, but there's definitely a bunch of room to add that to this design, I think. So some of that might involve changing the design of how the screws that mount the shell to these side brackets actually work, which could involve reprinting the frame. The annoying part of that is iterating on that design is a little bit frustrating, because you know, like, the attachment points are built into the rest of the winch and become really hard to change once you start mounting anything to them. And then, so the more feasible thing is to do the iteration on the shell side instead of on the winch frame. But then the shell is just a big piece of plastic, so I don't know. Which means that I'm personally maybe not as interested in iterating on it, but it is a thing that maybe future me or maybe other people end up doing. And then for just like mounting sound insulation on the inside of the shell, there's probably already some room. It might even be worth just taking some of the, because there are going to be some voids, I think, where there's just like a little bit of extra space that would have been awkward to kind of like have the shell kind of carve in right there. So maybe in some of those areas I could put a little bit of sound damping foam to just absorb the extra noise bouncing around inside the thing. But yeah, that's a good question. I don't know that it'll be necessary, but if it is, I think there are some options. I guess the other thing is I don't expect this to be solid. Like, I'm going to be including a lot of holes in this box. So that might make it a little bit less of just a big old resonator. Both for ventilation and so that you can see the mechanism inside. Let's be orthogonal. This program is really good at just zooming the camera completely away from my sketch. Alright. Right, so here you can see the reference points I used. So here I was making a tangent to that. Here I was following the top of that assembly. The front of this frame. Frame rate is pretty bad right now. And yeah, the power supply. So I was just kind of hugging the structure of this pretty tightly and ignoring this back because I figured I'd just have a cutout for that. And the spacing here I think was 5 millimeters. Yeah. Cool. So that should be plenty of room. That might even be too much. I think that's fine. I don't want to cut it too close. So then I just rounded these as much as I felt like and as much as I could without hitting anything really, and leaving enough clearance between that. So that's what all these fillets were for. Then this sketch, yeah, then I carved out the areas around. Oh, let's turn off the hidden lines. I've also got this thing where sometimes the monitor on my end just goes blank for a couple of seconds, so if I just start like waving the mouse like I can't see it, In that case, I couldn't. There we go. I think it's one of those things where that one's actually SDI, so I can't blame HDMI for it, but it might be another marginal cabling setup. Okay, so here, this is just cut to the same plane. So this is a bit of a design puzzle because what I'm designing here is not actually the shape of the enclosure. It's kind of a template that's then going to be put through a couple of other operations. So I'll be cutting it in half first. First I'll be shelling it. So I'll be taking away some of the faces and then hollowing it out, leaving those faces off. So these faces that you can see interfering with the bracket are some of the faces I'll be removing. But before I do that, oh yeah, and this extrude was taking off space for this whole interface. Why is that interfering? Okay, yeah, I'm just going to take off this plane. And this just leaves room for that mechanism to slide around. Okay, so I think the next step here is just to do the cut in this axis. Oh, I'm going to need the hidden lines back again. Oh, frame rates. Okay. So yeah, there's a lot I can remove here. Let's first get a projected copy of the body we're working on. At least the two sides, maybe. Well, actually we need this edge. We need basically the outline of this thing. Project is so slow. There's something project must be doing that just like checks everything that's visible. Because the more complicated this model has gotten, the slower every single project operation has been. Yeah, and I'll probably want to do something similar in that axis. Anyway, is that actually solid now? I think it is. Yeah, cool. All right, what angles can I deal with here? Maybe I want to be setting this angle. Oh, you know, maybe we won't be limited this on that edge. I don't think the angle we want is going to be limited by the 3D printer overhang. So for there, I might just define it based on this edge. Over here, we might be overhang limited. So let's actually delete that. And project this thing that disappeared. Okay. So slow. How much space do I want? Probably the same, 5 millimeters. What can I turn off? I mean, I can turn off all the electronics, right? Does that save me anything? And the spool? I think the gear was kind of slow to render. Yeah, there's something about the gear. Like, I think it's a polygon with a lot of vertices or something that the graphics engine here doesn't like. Okay, well, let's do this corner and then mirror the whole thing and then do the extrudes. So here, I think I'm going to want it to be parallel to this line if I can, but what is that angle? It's 29 degrees. I don't think I can do an overhang that steep. So, and that's probably fine anyway, because this corner here is a little weird, and like I would have to give this extra distance, and then it would cut kind of close to this corner. So let's not worry about that internal angle. Instead, let's just make an arbitrary line. Let's at least make it on this projected line. And let's just set this angle to something I can 3D print. What does 40 degrees look like? Because that's pretty easy to print. And maybe, is that what I want? Let's project this line for reference. Yeah, and so at its closest point, it's tempting to cut that a little closer, but I think I'll go with 5. That seems fine. Is that solid? Yeah. So now we can make a midline. And mirror some stuff. Man, I'm glad I'm not broadcasting on the same machine I'm running this on. This must be taking the slow path on everything in the GPU. So I think the simple way to do this is just to cut from the body that I've been working on here. Why is it cutting the idler half? This shouldn't be interacting with the frame, unless I got something wrong. Oh, come on. There we go. Idler half. So thinks we were cutting in. Oh, was I trying to cut off this assembly? Is that what happened? Yeah. Okay. Yeah, let's try that again. Oh yeah, I was thinking, oh, it just was on the side I wasn't looking at. But no, it's on the side I was looking at. I just didn't see it. Oops. Okay, so that's actually the end I've got to worry about. That's this edge. That tiny little thing. I think I might need more tea. Yeah. Let's try deleting that. Everything here is so slow. There's not much chamfer at all. That's fine. So many seconds per frame. Oh, I guess this whole thing needs to be a little wider for this assembly. The idea behind this cutout was to give room for this whole mount to, to not interfere with the shell even as it rotates. But I didn't leave room, and like you can ignore this because this isn't actually going to be there once I shell it. But this perimeter should not be interfering with these parts, so that needs changing too. Let's edit that before we get too far past it. So for that, we can actually go directly there if we just go edit profile sketch. Whereby directly there, I mean it drops you with a completely random camera location, and then you have to figure out where you actually ended up. Oh, this monitor is not having a good day. Hey Tuco, welcome back. Welcome back, picture. Okay. So basically we're looking for the point in this mess that is farthest from this the center axis. And so in this case, and I'm not worried about this one because it's far enough back that it's not going to interfere with this, but like within like this area. And so that, it turns out, is this edge right here. So we want to project that so we can use it for reference. And there's a few different ways to do this. I'm just going to do the one that comes to mind, which is to go from the center of the circle to an arbitrary point on here. Not the center, because that's not what I want. And then I'm going to make another arbitrary line I'm going to have these be perpendicular. I also want them both to be construction lines so they don't affect the profiles that get generated. So there, as far as I can tell, isn't a constraint that lets you make a line perpendicular to a curve, but you can make a line tangent to a curve. So that's what I'm doing. And now that I've got this line already, well, actually, I think the easiest thing to do next is to make another line. Make these two collinear so they're pointing in the same direction. And then this one will have a defined length. It's really easy to hit something in the background that you aren't intending to hit with the kind of auto selections. Okay, so this will be the distance away from that obstacle that I want to keep. Whew. There's not much in the middle here that's... So you can see this swath here is the cutout for this back section, and then this circle is the cutout for this area, and they're going to be really close together, so I don't know if they're going to be if it's going to be worth having them be separate. Anyway, let's make this 5 millimeters again. Actually, do I need that much clearance here? This is literally a cutout. So I don't have to worry about the material thickness that I was adding in otherwise. This is, yeah, so I don't need this to be quite so big. 2 millimeters should be plenty. I'm also just thinking about how the back of this case is going to look and trying to imagine what it even needs to have. Because the back does not need to do much. And for the most part, a lot of it, it could just be completely open on the back. Okay, let's keep going. What was I defining this against? See, that was supposed to be just the shape of the wall mounting bracket and its intrusion into this space. So I think the issue with that is if I try to just cut out the area that the wall mounting bracket needs to occupy, the problem with that is that ends up pushing. So like if I turn this body back on, everything here is going to turn into a shell of plastic and then hollow on the inside. So by pushing this in, I'm also pushing that shell in on the other side, and so I have to keep that from intersecting with this stuff that's right below. So if I'm going to have that layer at all, it needs to either be out here or above it. And then what was I doing with the extrude after this? Maybe I was just going in too far with that. Because it would be nice to have this be like basically a finger guard, to protect these rotating parts. I mean, it would be mostly aesthetic, honestly. Like, this does not serve much of a functional purpose, but it's nice to have something that kind of finishes the edge here and not just leave it straight and then flopping around. So maybe the mistake here is in going this far down, and I just need to have this terminate above this edge. Yeah, let's do it that way. Okay, plan A.5, my favorite plan. Oh. I guess I tried to do those both in the same extrude operation. Maybe that's a mistake. Oh, no? Yeah, that's what I did. So let's... Whoa. Not that, sorry. None of these profiles are what I want. Okay, great. So that's just coming down here. This needs to make room for this whole thing. I think it might... What does this look like at other distances? Am I keeping that or that? Well, so here's another design constraint that I've been working with. So this whole back wall mounting bracket rotates, and I've been trying to make sure that I have clearance even as that bracket rotates plus or minus 25 degrees. So I've actually got a couple of copies of the mounting plate that are rotated plus and minus 25 degrees respectively. So if you turn that on, you can start to see what this cutout is for. The main purpose of the cutout is to provide room for this. So really, let's just have this go to this surface, and then add an offset of like 2 millimeters. The purpose of that offset is mostly to keep them from rubbing together even if the plastic flexes significantly. That in the wrong direction? Nope, that looks right. Oh, 2 millimeters seems puny there. That might be fine though. Let's do 3. Let's compromise. And is this cutting the right objects? Oh yeah, this is a good question from Jeff, who asks, if the camera is close to the height of the winches and the paracord is mostly horizontal, the load seen by the winches would be several times the camera weight, wouldn't it? Yeah, definitely. So that's actually what sets the height limit of the robot. So all the winches will have feedback for how much load they're seeing, and you know, if you're trying to go too high, then you'll start seeing like all the winches are going to go out of range. So yeah, that limits, and the idea is that this works here because the ceilings here are much higher than I actually need the camera to be, so I just don't really need that. But yeah, if you were designing this such that you really wanted the working area to be like all the way at the top, then you would probably want, I mean, there might be a more clever way to do it, but I mean, you might just want like bigger winches or a smaller camera robot. But that might also just be something where like maybe, you know, like Rev 2 of this design, we like optimize everything and now all of a sudden it's just like way better at all of this and it can handle more force and the camera's lighter and all this. But for right now, luckily my space is pretty forgiving in that I can put the pulleys really high up. Tuco, you gonna join us? Do you want to be on camera, Kat? Ow. Do you want that cleared off? I can sweep this up off the floor pretty easily. Is that what you wanted to go? I made it clean for you and I pushed things off the table. Two of Kat's favorite things. He still doesn't care. That's what I expected. That's fine. Anyway. Yeah, 3 millimeters, and I was going to check to make sure this is only cutting the objects I want to cut. Cool. 0 FPS. Okay, so we've got the cutouts for the wires, we've got the cutout for that. You know, I think my strategy here was to make this cutout pretty large, or, you know, I guess what I'm saying is this circle can be, this cutout really only needs to provide room for this to stick out. It doesn't really help with this internal structure, so I think I just need to, yeah, I think I just need to make a cut on this back surface that moves that back edge inward enough to not, I mean, basically I need a face that I can delete to create an opening in the back. And so I think I need to decide on the shape of that and then probably do some extrusions along the back to both clean up the area around that opening and then to make the opening itself. I think that's where we're headed. So how did I set this circle? Am I editing this sketch? I'm not. Let's edit this sketch. Oh, what is that tangent to? What is that tangent to? Oh, this line. Oh, yeah, that's really overkill. That's not the right place. And what about this? Okay, so these are both unconstrained right now. So I actually care about this and this. Not that. That. And I think I just want to offset these to give myself some clearance. Maybe I'll use 3 millimeters again. I also did not care about this. That's just in the way. I can't do a distance between an arc and a point. I guess fine. Let's do... Oh, I kind of wanted that to be... Actually, this will be fine. Cool, so it automatically added the constraints to keep those parallel. So now I have two little things that I can set the length of. make them equal to each other. And set one of them to 3 millimeters. Eventually the dialog box comes in and lets me type a number. Okay, now is this useful? I think this is still fine. Yeah, that'll be fine, and I didn't actually end up needing this stuff. Okay, so that was the sketch. That looks fine. Oh. Oh. Oh, right. That needs to be, this side needs to be wider. These do not need to be even. So this comes down straight. This has an angle. That's one reason for this to be wider. The other reason is that you need to be able to lift this up to take it off the wall mount. So actually, let's change that. Where's that equal constraint? Okay, so this one can stay 3 millimeters. And I could choose a different reference point for this one, but I think I'm just going to type in a number. Because, like I mean, I need a little bit of extra room for this, which could just be like a bevel, but I also need a significantly larger amount of room to allow this whole thing to be raised up. So let's see how much I can get away with. What does it look like if I ask for like 20 or 30 millimeters? What does 20 look like? I've got enough room for that. I might also start setting a minimum distance to this edge at this point. What is below that? Power supply, right? Oh. That might be a problem. I mean, it's still possible to get it off the wall, it's just a little bit less convenient, because you can't just go loosen this top nut and then raise the whole thing up, because then the power supply will hit this bracket. So what you actually have to do is do that thing I just said, loosen the bracket, raise it up, but you can't raise it up that far. You'll be able to raise it up enough to get this over that edge. Man, that might actually be a reason to make this, to just increase the spacing of this a little bit. How much is that? It's the distance to the center, which is not what I wanted. That's also not what I wanted. That's what I wanted. Okay, so I've got almost 4 millimeters. Which I think is enough. It is just barely enough. Okay. So there's just enough room to lift this up and then off. In order for that to work, you'll have to be, at the same time as you lift this up and off, you'll have to be loosening the nut on the top, which is a little bit annoying. But that also means there's no point in making this any wider than this distance. You know, I mean, since it swivels, you could also just swivel it completely over. That would be fine too. That might actually be the easiest way to take it off. Swivel it over, and then lift the top, because the top has a slot that lets you lift the nut out. Oh, actually, yeah. That works completely, so it doesn't even need to be able to move up until after you swivel it. So you can loosen this nut. With the nut loosened, this will be free to swivel. Then you swivel it past the edge of the lower end stop. Then you can just pick the whole, then you can, well, assuming you've loosened the nut enough, then you can just pick the whole thing straight up. So that should actually be easy. Okay. I've convinced myself I don't need to worry about this as much as I have been. In that case, man, plan A.5 sure is popular. So I can go back to not dimensioning that. And instead, I'm just going to use this edge because that's convenient. That's also exactly what I was using before. It's convenient and it's about the right distance, and it'll look visually nice having these be the same, be aligned with each other. There we go, equal diameter. I think that's fine. Okay, so we did that sketch, this extrude, so we're not worrying about the internal mechanism yet. We'll do a separate cutout for that, but this has space for this even as it swivels over. Oh, is that what I want? This part. Oh, that'll end up getting cut off in the next operation anyway, because I'm making space for that internal mount. Okay. I'm not worrying about that yet. I think the next step is this extrusion. Oh man, CAD makes me hungry. Actually, maybe what I'm feeling is not hunger. Maybe it's more like it makes my stomach upset. I don't actually want all of these lines. I think some of them were on the plane that I started the sketch from. really nice if there is a like select all, deselect all for this, and if the box for the, oh geez, for these wasn't always so little. Maybe this is when people start using selection sets in this program. You can also get stuff to not appear in this list if it's not visible, which can help. Oh, why does this get even smaller? Is that just the end of the list? Okay. Oh, that is the most infuriating. Okay. Okay, so right now, this cut is only concerned with making room for the mechanism swiveling against the wall. This is not about the internal pieces. So... oh, and what is that? I'm getting distracted by this thing. That is just the weird shape of... yeah, that shape comes from this port angle right there. And the nut. Anyway, I'll be cutting out all this stuff that's flickering in a sec. I think from this, I just want to go to this edge plus 3 millimeters. Yeah. Okay, so that's starting to give me a much better surface to start hollowing out. I mean, it still needs a lot more work, but it's starting to take on a better shape. It's starting to look more like an enclosure. I think I want to do this back section next. Let's ditch this sketch and get a new one. And I don't... so I think those cuts made room for these mounting plates. Let's just make double sure we've got the other angles covered. Yeah. Sure, it's slow just to make things, just to change the visibility sometimes. Anyway, I'm done with both of those pieces. I need to turn on a bunch of these internal parts again. So I don't actually need the spool. I guess I also don't need these nuts and bolts. I don't need the motor. I don't really need the electronics, since the electronics mounts pretty well delineate the shape of the electronics. Rollers, also pretty well delineated by their housings. Let's keep that, because I want to keep those wheels in mind. And then definitely these. Okay. Ah, that's a little more manageable. Oh, so good question from Sam, if I could scoot the PSU forward. It would make the case bigger if I did. All of those things are pretty well in the spot that they need to be in. So for example, if we look at it from the top, like scooting the power supply forward the two problems there is it leaves less room for the wiring up here, and yeah, I would maybe worry about that more, but I think since we can just take this off the wall by rotating it past the edge of the bracket, then I'm not even gonna fuss with that. I think this is already a pretty good balance in location. All right. Let's do a sketch on the backside. Okay, so we're no longer worried about things swiveling with respect to each other. That axis of rotation was just for the wall mount bracket. This shell and the internal parts stay fixed when they're assembled. I don't know if I want the cutouts to be asymmetric like the inner mechanism, or if I want to just draw a rectangle that's centered around the back. I'm just going to see how a simple rectangle looks. Let's first get a reference point. Like, this bolt hole is pretty reliable. Let's use this. Those sound like some birds Tuco would be interested in. Arbitrary rectangle. And... that's from the body of this that we have hidden. So this is really my extreme point right here. The rollers and the cord do actually stick out past this, but not until you get past this support area right here. So for the very back, which is what I'm worried about right now, this is a fine reference point. A lot of this doesn't really matter that much. It just kind of changes the strength and aesthetics of the back of the shell. Oh, I should also be really thinking about printability. And, I mean, maybe the simplest thing to do, honestly, is just to leave out this perimeter also, and have the shell basically just end at this face. I still have to trim this area. Oh, and there's this. Hey Tuco, you're walking on my desk. What key did you even just press? This part where it comes back in is not going to be fun to print. Okay, I just want this to end somewhere in the middle of this arc-shaped cutout. Yeah. I can actually make these as tangent. I don't really like this, but I want to see where this goes. Oh, Tuco's got a good spot. I'll use the manual CAD cam. Hey, Tuco. I hear you, Tuco. Maybe this is fine, actually. So the goal here is that after this cut, I would, during the shell operation, discard this big flat face. So that would just be an opening, but then these sides would have an opportunity to kind of fold back over. And I'd probably fill at this edge so that it's not so sharp. Or give it kind of a severe chamfer such that it's even fairly printable without supports. And then on the top, what's going on here? I don't think I want it to go all the way off the top, actually, because I want a similar effect on the top support. Let's go ahead and save this, but then I just want to go back and edit the sketch right away. I hear you, little guy. Tuco, that's a USB hub. Whoa, what are you doing? What are you doing, Tuco? Is that a bug? I think he's hunting. Yeah, let's use this. I don't think, do I have anything on top that would be in the way? I think I tried to keep that area clear, right? Oh, that roller. So... Oh. Sharp cat. I think I want to give myself some margin to give the... There's a roller right there, and I don't want to get in the way of the roller. And there's plenty of room, so maybe I can get away with 10 millimeters. Maybe I should just take it all the way up to this edge. Although, like, that kind of curled shape will actually give it a lot of strength. It just looks weird. And it'll be annoying to print. Let's go back to the sketch. Tuco. Yeah, is he hungry? I thought we had dinner, but you know, I've been known to forget meals. Tuco, I feel like we just had something to eat. Then again, the stream, I guess it's only been going for a couple hours at this point. Oh, what did I just delete? Oh, this UI just keeps freezing. It's like, oh, let me load your undo list. Okay, I think I accidentally undid that project. Oh, let's just make those equal. Well, coincident. Okay. I want to know how this edge is actually going to interact. Maybe section view can help me do that. So this piece again is going to become hollow in a bit. Yeah, I think I can work with that. That's probably a good step for, or a good state for this to be at right now. I think the next thing I want to worry about is the area around the e-stop switch on the front. And so I want something similar there where there's kind of a fold where the edge turns inward so that it's not floppy right there. And then I'll do some fillets or some chamfers or some fillets and some chamfers. Not like giant ones, but to smooth out some of these edges. Oh yeah, and can I cut it along this plane? I haven't done that cut yet. Is there much to save? Oh yeah, definitely there's some stuff around the power supply that I can cut down, and some stuff up here. Yeah, okay, let's do that then maybe. We could do that or the switch area next. Alright, let's do the switch. Keeping with the theme of plan A.5. Let the projection tool page in. Alright. I needed those hidden lines. Let's let the hidden lines load. Mikey says, half the fun of designing something in Fusion would be just looking at it with the fancy space mouse. Yeah, it is nice, especially when the frame rate's not terrible. I think I want this to be kind of shallow so that I don't really have to worry about running into this support member. So I'm just going to draw a rectangle and then offset it by a small amount for, like, just so that it fits all right, like maybe 0.5 millimeter. Maybe 3/4 millimeter. A little shy about 0.5 millimeter there. And then since I really only want to work with this outer one as a profile now, I'm going to break the inner one by setting at least one of the lines to construction. These should be construction lines too. Okay, let's see what happens if we extrude that just a little bit. So we're really worried about hitting that. This vertex. Not that vertex. Uh-huh. You're not giving me the selections I want. Is that? Oh, that was the right vertex. It just didn't highlight it, so I would have had no way to know other than just guessing. Okay. And let's see if we can also get by with a negative offset of 0.75. Oh, is that the wrong direction? Yeah. Oh, am I going to cut too many things? I forgot to check the list of things it's cutting. I think it's going to cut everything. Yeah, let's fix that. I hate this tiny window. This is the stupidest design. Come on. All right. I think that's a start. So I can remove this face when I do the shell operation, and it'll give me a little bit of extra stuff around this edge, which I think I might want to add to after the shell. Okay. Next is this axis. Yeah. New sketch. Okay, so this I think is going to be limited by the angle that I'm printing overhangs at and this piece down here. So let's project that. I also just need to make like a bounding rectangle around this whole thing. Jarrett says, I think there should be a send feedback button on every single GUI interface. Yeah, except, yeah, they'd find some way to ignore it anyway. I mean, I've often thought it would be fun, well, fun, potentially useful, if there was some way for the developers to get harassed every time the interface just freezes for several seconds. Like if it doesn't maintain 30 frames a second, like it seems like that should be a bug and not just people throw up their hands. And I mean, this is acting like it was designed with some good like multi-threading and stuff, just that there's a huge pile of bugs in it. We want this edge. All the projects are so slow. And you have to wait for all the wires to load. Okay, the corresponding edges over here are this one. Can I project just the vertex? It's hard to know if that's the right vertex. I don't know if it was. Oh, yeah, it was. Okay. Oh, now I can project an edge. Okay. Thanks, selection algorithm. All right. Let's keep things planar. No, I said planar. Sometimes you gotta lock the space mouse to keep things planar. Okay, angles. Like 40 degrees seemed safe. Like if I'm pushing the printer to do really gnarly overhangs, then I'm not going to get good results. So I might as well keep it relatively reasonable. What did I just do? Oh, it looks like maybe... Oh, can I push that? I don't know if I want to go any steeper than that. Alright, well I guess I need this bottom bracket too. Can I do that? I think I'm gonna need... Oh. That's not quite what I wanted, but that is totally close enough for this purpose. Ah, that is not. No. That is not what I wanted. I meant midpoint of this circle, and perpendicular to that is close enough. For this, though, I want my margin of 5 millimeters. This is also not exact, but plenty fine for what I'm doing. Top side. Okay, so these... Oh, technically that one's closer. I don't really care, though. Okay, let's extrude. Yeah, it's always great when things are this slow. Okay. I mean, it does get faster when I hide large portions of the design, but like I've already got the electronics and the spool and a lot of the bolts and nuts hidden, and this is still happening. This is looking nicer. Is that... Okay, so that's like real space taken up by the power supply. And this is mostly following the form of the interior parts. Oh, we broke that edge. I don't like how close this top edge is. Yeah, let's try making it not so all the way up there. Yeah, we're on 5 millimeter margins here still. Oh, you know, maybe that's too much. Because here we're still talking about the outer edge of the shell, and in this case the outer edge of the shell is actually going to be up against this piece. So actually, maybe I can bump this down to more like fit tolerances, like a 0.5 millimeter in that kind of vicinity. That would be a big difference. So that's still over that edge. I don't want that to be quite that, because I'm also going to have to take into account how this is pretty far away from its mounting locations, and so any flex in the plastic could be more severe here. So I just don't want to rely on super tight tolerances of that interface. I think I can get away with one just fine. So that's already symmetric. Then This top area is harder. Well, actually, things only start getting mechanical past, where is it? Momentarily completely lost my bearings. There it is. So these rollers, yeah, so the wall mount is on the right here. And these rollers are going to have moving parts sticking up out of them. But the thickness of this wall here, which I think is like 4 millimeters, that's plenty of room for this cut. So in that case, that was 1 millimeter. Let's also just make this 1 millimeter. Hey, train. Okay. Oh, there's so much going on here. Okay. So this face is getting removed. This now turns into the border of our case. That's cool. These sharp edges I'll take care of. I think I need another cut in this area. I think this part is going to be fine. It would be nice if I could make these edges line up, maybe. I mean, I can also just round that. This I don't actually want to come in that far. It's mostly just for stability on these edges. Then I'll do another cut down here, so maybe not 20 millimeters. What does 5 millimeters look like? Well, I guess it needs to go all the way down to this level at least. That seems about right. No, that wasn't enough. There isn't enough of a mount, like a rigidity lip up here now. Yeah, and that was the equivalent of 11 millimeters. Well, let's just do the shell for a sec and take a look at what we've got so far. I think that might be instructive. Shelling. Okay, let's actually look at this with the other parts. Yeah, I don't think that actually wants to be there. That clearly needs some trimming. But this is basically how this is going to mount. I'm going to probably add some reinforcement around this edge. I guess I should really do that by creating sketches on these faces before shelling and extruding them in. I mean, it's also easy enough to make a sketch on the inside of the shell and then add that back while I'm building up the screw mounts. That needs to go. Let's go back to the section view. Yeah, that's a little nicer. And now you can see kind of this curl in the back that I was talking about earlier. Some of that I want to keep. This edge I might want to keep sharp, or at least fairly sharp, but this one I can kind of round. Here you can see the little bit of extra support I got for the switch, and so I can maybe build on that too. Similar mounting areas over here, that's where the screw would come to. Okay, this isn't too bad. Maybe I want to cut off this face and that one. Okay, well before shelling I definitely want to do whatever shape changes to the edge profile. So like rounding edges, making it look less boxy. Okay, so I just wound the history back to right before shelling. So each of these sides will be printing like this. So rounding this edge makes it harder to print. It's harder to print cleanly. Having this edge be sharp is probably a good thing, but these sharp edges are unnecessary, and I can probably make this look nicer if I fillet those out. And similarly with this like overall edge, I can fillet that. But probably want to do those separately. Where are those internal conflicts coming from? It looks like I'm hitting the power supply on this side if I do too much of that. That seems fine. That's what, 20, let's do 25 millimeters. Oh yeah, that was a good question from Sam about the holes in the spool, and a great answer from Jarrett. Yeah, those were for thermal relief because I was having trouble with them warping on my printer. Okay, let's try these edges. I can't even that radius. Cause I can get up to 6 millimeters before it fails. That might just be because of the distance between that and this edge. That's fine. That's better than not rounding it, I think. You know, maybe I can get away with such a small fillet on these edges too. I think that's nicer. It still looks super boxy. I mean, it kind of looks like a, I don't know, like a James Bond villain weapon that's made out of a oversized lunchbox or something. I mean, the overall shape is definitely optimized for printability rather than aesthetics at this point. You know, I was thinking at one point of putting some LEDs on this. I still have not actually left any room for those, but they would go on the shell if they were going anywhere. Now I'm just imagining this with like, if I put anything on this, it's gonna look like a face, right? At least it probably will to me. Oh yeah, Fred says it needs eyes. Yeah, that's true. Maybe LED eyes or like just googly eyes. It does look like it's like, I don't know, like sucking on a big red emergency pacifier or something. Yeah, where do I have, or like how much room do I have for LEDs if I wanted to do that? Not that this project needs to be more complicated, but like the software already supports it, so I was kind of planning on having LEDs, just didn't really include them in the design yet. And there's room there. Let's think about that. I think it would mostly just be creepy though. Like my original plan for the LEDs was to basically have a vertical strip that could move in a pattern that is corresponding with the motion and then have colors indicating errors and that kind of thing. Also, I have to keep reminding myself that there's going to be a lot of cutouts in this, so it's not necessarily going to look as boxy once I start cutting out ventilation and see-through holes, but it kind of is. If I filleted this instead of chamfering it, it might look better. It would also print a lot worse, I think, because the steeper angles near the bottom of the fillet would not print well. And so you'd end up with this kind of patchwork of different print quality levels in the result, whereas with this, the overhang angle is mostly constant. I mean, this is also designed such that I don't have to 3D print the side panels. It's just probably what I'm going to do because it's easy. Hey, Tuco. Oh, why did I cancel that? I forgot I was still previewing. Okay. 6mm. If it will ever finish. Oh, good question from Sam, who asks, what color filament are you thinking? Yeah, I hadn't really decided that yet, as you might guess from this being kind of gray. And I'm not sure if this is the final color either. I don't know if I'm actually pretty low on this like cyan filament that I used for the frames of the Winch bot, and I don't know, I could just print this in black PLA. I actually have a bunch of black PLA, and if it's just like kind of a nondescript part of the wall mount, then maybe that would be a good color. Let's break out the appearance panel here. I could also order some PLA. I probably have some time to get a color I don't have in stock. Why can I not get appearances? I'm pressing A. It's probably off screen. Oh, save is so slow. It probably saved the window location when I was running this on my 4K monitor, and now it's off screen. I'm not really sure how to get it back other than to go back to the 4K monitor. I could change the resolution without changing screens, I think. If I turn on my other monitor and then turn on mirroring, I think we can do it. Or I could just go to the other monitor and move the appearance panel somewhere we can see it. There we go. I just had to temporarily use the 4K monitor. Oh. Did I already have black plastic in here? Alright, so there's that. And you will be able to see some of the internal parts, which are blue and red. I've been mostly using red for sort of accent color on moving parts, or I'm also probably going to print the power supply brackets in red, but I might not. And then the frame parts have been these two different shades of blue. Hey, Tuco, I hear you. Where's your bolt, Tuco? Oh yeah, this is not a native Windows interface, unfortunately. I probably want to keep it to either a shade of red or a shade of blue. I don't think I want to introduce a third color into the design. But I'll have to look in my filament stash and see what I got. I mean, maybe a brighter color, I don't know. What would green look like? That's another color I have in stock. That's not green. That's probably way too green. That green is broken. I don't want to make the whole thing red. Making the whole thing that kind of cyan color is kind of nice. That was actually kind of my original plan. Yeah, maybe I should just get some more of this filament, because I'm kind of low on this color, but this was originally what I was going to make the enclosure out of. Okay, let's go forward past the shell operation again. So this is one of the places where the shell is going to be held on. So there's room for some extra support in here, and certainly room for a sound dampening washer. Damping. I guess we're not making the sound wet. And I still haven't quite decided what to do with the cable exit. I assume... yeah, that should probably happen before the shell also. Yeah, that should definitely happen before the shell. I mean, basically any large hole, I'm going to want some kind of curve at the edge to give it additional strength, or at least like a thicker area, but like a fold at the edge, kind of like the top of a paper cup. It's really nice to give this stuff strength. Oh man, we're getting really close to the encoder. That could be a problem. Oh, I think I designed this without the electronics visible. That's gonna be a problem too. Man, CAD is so relaxing. Said no one. I mean, I think CAD can start out relaxing, but at this point, I don't think it's relaxing. What can I safely turn off to speed this up? Not that. Actually, where is... I guess the encoder isn't in electronics, the encoder is in measurement assembly. Yeah, I feel like the opposite of, so like James says CAD is relaxing when you don't have any real constraints and when you don't know what the output should look like yet. That doesn't seem like engineering CAD. That feels like kind of like art designy CAD, which is usually not something I would do in this program. That's usually something I would do in Rhino, and that can be super relaxing. I agree. I think the thing that makes this, I don't know, like I find it not relaxing when you don't know what the shape is yet, but you know it has a lot of constraints involved, and like part of the process is discovering all the constraints and then realizing them. The black plastic wall mount bracket definitely makes the winch bot itself stand out with its bright colors. Oh man, I'm running low on steam to do this sort of CAD. To go. Also, this whole area needs work. Okay, back to before the shell. Let's make a spot for the cord to exit, maybe. Hey, what do you want, Duke? Duke, are you hungry? No? I don't think it's food. I think he just wants attention. But I haven't decided, or haven't discovered what kind yet. Hey, Tuco, what do you want? Not that, okay. Okay. What a cat. Yeah, so as I mentioned this on Twitter recently, but started, when I can at least, try to simultaneously use Fusion 360 and Final Cut Pro because they both like to freeze so much. Although I'm trying to do that with like a KVM switch, and the switch itself has a delay which gets annoying. So I might just try putting a second mouse on my desk. Oh, there's a bolt, isn't there, Took? I see it. Okay. So I want this centered approximately where I think the center of the cord is going to be. So let's set that to maybe 2 millimeters. Maybe 1.5. I think the cord's maybe around 3 millimeters diameter. And then this, I actually probably want it to be fairly large because I don't... Like the cord, I mean, I want this to be installed such that the cord is... Oh, Tuco, hey, what's going on? So I have this pivot so I can angle the entire thing, you know, in this axis. So the cord shouldn't be riding up against the edge of this pulley. So the opening here doesn't need to be super wide in that direction. But I haven't included a facility in the mount for like angling it in this axis. And the assumption is that it would already be pretty close. And being off axis in this direction, that affects the accuracy of the force sensor, but it doesn't cause friction on this pulley assembly. So having that not easily adjustable doesn't seem like as big of a deal. And because I'm tolerating more inaccuracy in that dimension, I want the hole to be wider in that axis. I don't know if I want to do something with like an ellipse or just use a rounded rectangle. Let's see what an ellipse looks like. I don't know, something like that. I'm just going to dimension this to something round. 45 maybe. And 25. All right. It's worst when the cut goes through a bearing and then each ball in the bearing gets its own entry in this list. Can I turn off the measurement assembly? There we go. That's better. Did I not want to go through that edge? I guess not. In this case, let's appease the geometry gods by going a little bit further so that we clear that line. And this is just to build up that little bit of a reinforcement on the edge once I shell it. Maybe a fillet would be better there, actually. that to the shell. None of those. What will it take to select the thing that I want to select? Hey, buddy. I gotcha. Okay, let's just start over. Why is that not selectable? Okay, let's delete that and try again. Shell. What? Oh, tangent chain. It was expanding my selection because it was following everything that was smooth. That's not what I wanted. Okay. That's better. Actually, let's do some more chamfering. Oh, can we take care of these first? Actually, let's take care of it from this side. Can we not just subsume that corner? We can approach it. Will it get any better if I do that too? No. So it will not blend two chamfers into each other, but it will blend two fillets. Okay, so that I'm doing as a fillet because I kind of have to. The others, I kind of want them to be chamfers because I want them to be geometrically simpler, and I'm not using them to provide smooth edges like I'm using these these fillets for. I keep expecting the C key to be chamfer and not circle. think that edge needs a fillet instead. And this chamfer isn't necessarily working like I want it to. Well, that's going to just bend inward a little bit. Yeah, I think that's superfluous. Let's not do that. I'll go ahead and add that fillet while I'm thinking about it, though. Really? Okay, so I'm removing that. That one, let's actually chamfer that. I think that's actually what I want to do here. Yeah. This is again, not for the thing itself necessarily, but for the thing that happens after I run the shell again. It'd be really cool if it stopped hiding all the lines that I care about anytime I move. Like, it sucks when Rhino gets down to like 5 frames a second, but at least it's showing me stuff I care about. And then sometimes it just draws it all like this. Why? Yeah, maybe this bottom edge gets dealt with that same way with a chamfer. Can I not do 3 millimeters? I can do 2 millimeters. That should be fine. 2 millimeters is plenty. I think since that ended up kind of breaking the smoothness too, maybe I will... Well, I don't know. I was going to say I'll do like a 1 millimeter fillet just on this edge, but let me do the other sides of this first. So yeah, these 2 edges I'll use a little chamfer for reinforcement. What am I doing with these edges? I think maybe this edge gets removed also. Yeah, okay, well I still need to do a cutout for this thing, so I'm not going to worry about that yet. But let's do this chamfer. Alright, 2 millimeters. That looks fine. Jared asks if there's a way to lock parts of the model so they're visible but can't be modified. There might be. I wouldn't really trust that to make it any faster, if that's what you're getting at. I think I want to chamfer this edge. Oh. Yeah, let's deal with that later. I can't do that before the shell super easily. All right. How about... I think we're looking at a sketch on this surface, maybe. I feel like this shell has been one of the easiest parts to design so far. I mean, some of the parts, I don't know, the parts at the beginning were pretty easy, like, you know, oh, I just need to make some pulleys, this just has to interact with a couple other things, but then, like, making the mounting brackets for the electronics just got super complicated because they interact with so many things. Let's project some lines. I think I want this to mostly line up with the same edges, but to go deeper. I'm just like poking the space mouse and it doesn't move. Yeah, I feel like, I mean, in VR you have this problem where you have to continuously render, otherwise you get simulation sickness. But I feel like that problem is still there outside of VR. People just get lazy about solving it because you don't have vomit to clean up afterwards. Yeah, okay. I'm basically just making something that protrudes, or something that, like, allows for this protrusion. Okay, I think this intersection over here might just be among several surfaces that are all getting discarded. So that might not be a big deal. And then on this side, how do I like it? That seems alright. Maybe I can take that down until it hits this surface. No, this one. Could really use some lines now, renderer. Lines, thank you. Lines, thank you. I need a break right about there. Oh, actually maybe I don't. I think maybe I'm planning on removing both of those surfaces. Okay. I mean, does that actually work? I don't like how pointy this gets. Yeah, no, I think I do want a break there. Let's add that. Yet another thing that needs to happen before the shell. That goes on this surface. At least now I know what shape it is. That was not the constraint I wanted. Tangent, thank you. So this is going away. That is staying. Yeah, I think I can do that. Gimbal lock. No, seriously, what happened? Okay. Sometimes the Space Mouse loses an axis until I somehow reset its input driver. It's only ever happened in Fusion 360. Can we has line? Not over there. Oh, there's the tangent constraint. Hiding right next to the midpoint. Okay, so now this piece is staying. . 'Cause Can we try the shell again? I could also divide that, couldn't I? I probably should. So I was thinking about dividing it like from there straight across so that this section would actually be open. I could also just make a cutout just around this area. I could also just take it all out. I just kind of want that to not, like, because this isn't going to really have any support otherwise. Yeah, okay. Back to this. Oh, I don't want to go all the way out there because I don't want to disturb that. That's part of my little rolled edge that I'm keeping. I just want this. Such train. Okay, and this will give me some edges to discard. Oh, that corner is not nice. I don't even really want a displacement. I just want to split this polygon. This is gross, but I'm just going to do a very small number here. Same thing on the other side. Okay. I'm trying to work through all the ways in which that's going to bite me in the leg in the future. Okay, let's try going back to the shell. What did I even just select? I don't think I selected the face I meant to select. Can we clear this up a little bit? Maybe I don't want hidden edges anymore. Tuco wants to hang out outside. It's too late for that right now. This is seeming a little better. Not tangent chain. Always good when it leaves the wrong cursor active. Really instills confidence in a UI. Okay, so I've got a hole for the button, for the rope, for all this stuff on the back. And I've got that little rolled edge, which I'm hoping helps. Okay. Let's try this. 1 millimeter. Oh, are you failing? Really? No. Is it having trouble with my terrible edges? Oh, that's interesting. It's giving me a suggestion here. So it says the body can be repaired after deleting faces. Try changing the selection or use the delete tool in the patch workspace to delete geometry without repairing the gap. Maybe that's what I want. Because this thing I'm doing right now is kind of absurd, using a solid to make a thing that isn't really a solid. A2Go. Oh, 0 FPS. And then it just brings back a random background window. Thanks. I wasn't using that anymore. Okay, patch workspace. Huh. I'm just gonna try to delete a face and see if that works. To go. Okay. Okay, maybe instead of, okay, let me backtrack a few steps. I think this is the right thing to do. I also think that the tiny 0.01 millimeter extrude is probably going to cause problems with this, so let's undo that. And I think in this workspace I can probably, like, I imagine I can find a better way to do that. I think I want to undo all of those. Tuco. My cat really wants attention right now. are you doing? Is it still? It's still undoing. Okay. It just moves the camera. Okay. Are you actually done with that? Okay. So that's all one face. That's all one face. What was the next thing in the undo buffer? Who knows? Ah. Okay, that's fine. Alright, patchwork space. Hey, buddy. This is nicer. So if I'm in the patchwork space, delete is a different kind of operation. This is a surface delete face operation, not a delete and not a remove. Okay. It's kind of relaxing working with surfaces instead of solids, actually. Still slow. Hey, Tuke, did you bring it back? I missed that part. Yeah, there it is. Tuco, you're so much better at this game than I am. He doesn't get distracted by all this other stuff there is to do. Although maybe I am getting tired-ish. This is all assuming I'm even going to be able to shell this. Thicken. I guess that's what I want. Okay. Can we cut these then? Hi, Tuco. Meow. Hey. Faces to split. Oh yeah, we're splitting faces. Ah, neat. Yeah, it just takes a while. Yay, that's what I wanted. Splitting faces. Another one of those. Same sketch. I certainly like working with surfaces. I mean, Rhino, which is another tool I've used a bunch, is all surfaces, and that one seems to be useful for designing shapes of things like cars and jewelry. I don't know if that's used for like a whole car. I think it's more used for like concept sketches though. I think I'm about ready to try thickening the rest of this. Let's make sure this is not interfering with anything. Can I see shells on the section view at all? Kinda. I don't even get a bold outline though. They're kind of hard to see. This is fine. So open. Oh, that still shows up as a body even though it's not solid anymore. Interesting. So thicken. It's hard to tell which direction it's trying to go. Oh, it's not working here either. Am I going the wrong direction? Where does this break? It gives up after like 0.1 millimeters. There must be something where it's self-intersecting and then it isn't able to correct for that. I mean, there's obviously going to be a bunch of self-intersections if you just do this naively, but I thought it was going to try to not do that. I might have to do this in a few different pieces and then clean up the result. Imagine stuff like this is not easy for it to deal with. Well, okay, I thought some of these curves were going to help, but clearly not. Let's delete some of the little chamfers and fillets. Because I thought that was going to help me build up a little material along the edge, but instead it just completely confuses the shelling algorithm. So where are those for us to delete? these might have been problems too. Where did that even come from? This one. Those two both seem useful. Let's try this again. Oh, is that working? This blue thing, that's helpful. Dang. You're rendering this with the least detail possible. Huh. How do I avoid that? Is that the mode I want? No. These mode settings don't really control how it works as I'm moving the mouse. It's like doing something else automatically during camera movement. I'm just gonna see if that's right. I don't know. I can't even see what I'm doing. Okay. The thing I'm most worried about is whether that extruded in the right direction. I think we're fine. That is not useful. Who designed this view mode? Okay, that's the shell. Okay, that's working. I think that must be a graphics bug, because if I make them visible in a different order, I get different results. So here's just the shell I started with, which should be the outside of the surface. Then when I turn on the body, you can see I've got the additional surface on the inside, so that looks fine. So we don't need this anymore. Oh, man. Okay. Well, we can inspect this a bit. The next actual thing to do might be to cut it in half. Let's try the section view at least. Let's also save this. I keep getting the sinking feeling that this thing is just going to crash any minute. It takes so long to save. Like, it's still saving. Can't do anything. Did you finish? Cool. Okie doke. So, 2x4. So all of this back here is open. I think that's probably fine. That's the other thing is, like, this case, I'm not really going to be able to soundproof it that much because I'm planning on having a bunch of slots in this. But maybe some different shell design. Like if it turns out I do need soundproofing, then I could redesign the shell without designing everything else again. Stuff like this, to make it printable, I could just extrude that straight down. That's easy to deal with. I'm just thinking about printability as well as the final assembled state. That's where the lower mount comes in. Oh yeah, that's gonna want maybe a little reinforcement too. You know, I bet my 3D print might be done. I haven't, yeah, okay. That's what I get for not having a camera. Maybe temporarily I will use my cell phone camera to go in there while we change over the print. Oh, a tooth goes on the floor over here. The orientation sensor in my phone is busted. It's possible that sometimes you can get it to register a change. I think I might have, yeah, I might have locked it, which is probably a good thing, but can I get it? Okay, maybe this is going to be even more cheesy than expected because I can't actually get my phone into landscape mode. Okay, well, let's do this anyway. So we just finished printing in one of the blue filaments, but the next piece isn't red, and I'm using up the last of a roll, so we'll get a beep in a little while when it's time to change rolls. Oh, that's a good idea from Sam, that I could design the vents to try to counteract the sound wave, like filter out some of the sound wavelengths. Yeah, I wonder if that would be physically practical depending on the kinds of sounds I'm trying to filter. Well, let's take a look at this piece that we just got off the printer. Hey, Tuco. Add that to the mess I need to sweep up. I know I'm going to get some of that in my cup of tea, which is empty, but I plan on refilling it. Hey, Duke, do you think these are interesting too? Delicious. Alright, this is not fully clean, but it's almost clean enough to test fit. You know, I have a microcontroller that doesn't have a bunch of stuff connected to it, which we could use to test fit the MCU. First, I kind of want to just shove this onto the motor and see if it fits. So this should roughly fit right in here. I'm just going to scoot the wires out of the way in an impractical way. Ooh, yeah. That'll be great once the screws are actually in. Sweet. Here's a microcontroller board we killed earlier. No danger for electrostatic discharge in this case. Oh, there's some support material in the way still. Oh, that's great. It's almost like I designed it to fit. And there's the RJ45. Oh, yeah, this one, Jarrett was asking what killed it. This micro died in the same event that killed my L298 motor driver that I was using before this one. So yeah, I don't know exactly how that happened, but I think it must have been some kind of internal short in the motor driver as it blew out, and then it probably shorted 24 volts onto the incoming 5 volts, and then blew this out. This actually still runs. It just draws way too much current as it runs and gets super hot, so not the best thing to be using. But it works all right as a mechanical mock-up. I could also use this as a programming interface because I think the programming MCU might be fine, although I haven't tested it yet. But it didn't seem to be drawing a lot of power or getting hot. So it was probably high voltage coming in through the GPIOs on that micro and causing a short in one of the clamping diodes or something like that, or in a couple of the clamping diodes. So this is designed to go in with heat set inserts, so I'll be pressing brass inserts into these holes and then these hold on. Those are not super strong, but they're definitely enough to hold circuit boards on. And then like These are held together with really long M3 screws, and they're also held onto this frame with shorter M3 screws. Alright, that seems good. Let's put this aside. Oh, man. I might have to take off in a bit and get a snack, and maybe even get some sleep eventually. Oh, but do we have any more of this in us tonight? Wow. Yeah, I think I may be feeling like this is an alright stopping point. So I've got a shell that is close. Let's at least make this a good color. Let's at least look at our design as a whole and export it and all that and make sure we have a good saved copy, but I think I'm done with actual design for tonight. Let's try just making this another shade of blue for now. Okay, so this is what we've got so far. This is much more satisfying than the shell without, or than the surface without the working shell was, I think. I wonder if this big gap is going to be a problem. That might be something I change. Like, this was all operating under the assumption that I wanted to just make a uniform rectangular gap here, but maybe I don't. This face has to be exposed. I don't have room to make it entirely internal because this part of the face over here has to be exposed. I could have the shell be just barely over that, but I don't think I want it to be cut that close. Anyway, that might be something I do to this design. I might redo parts of this so that this back is not quite so wide open, because I think that might be just a hazard of getting like people, or I mean, I'm not worried about like people sticking their fingers in there so much as I'm worried about my cat, but it's probably easy to fix. That would also mean that I get something connected to this edge, which would be nice. I'm also curious, like, what order of magnitude of printing time we're talking about at this stage of design. So without any cutouts or anything, can we just temporarily try slicing this? Oh, Peter's asking if I'm going to be splitting the shell in two or bending it around or bending it apart. Yeah, I'll be splitting it in two. I haven't gotten to that part yet, but I'm planning on just cutting it in half and then kind of building up the area around the perimeter and then making kind of like a little S-shaped lip so that there's some overlap that holds it together. That was what I did in the previous shell design, but we're on a new design now. This is not the right orientation. Yeah, so this isn't going to be realistic because I'm going to turn supports off, which is not going to print correctly, but I think this might give me around the same total print time as I would expect from the whole thing. And I'm going to be removing slot material, but I'm not sure that's going to save a ton of printing time. 25 hours. So that probably means that I can get each half of it into like a 12 or 15 hour print or so, which seems reasonable. Cool. And these will also be something that I can keep printing these while I'm working on the rest of the software and everything, because they don't affect the operation of the Winch at all. They're just for safety and to some extent aesthetics. All right, well, these need more work, but I think this is all I'm doing tonight. Thanks for joining me with the CAD. I know this isn't the most exciting thing I do on the stream, but it's still a thing that is a major contributing factor in the work that happens, and so it's nice to share that. And sometimes it's interesting. In case you missed it earlier, this is the project we've been working on. Tuco Flyer. It's a camera robot that operates on these 4 winches. So there's a little bit of background on it if you go to the Hackaday.io site and search for Tuco Flyer. All right. This is what we got so far. It's looking more like an object. And if we just turn off that shell, just for reference, there's all the stuff inside it. Actually, it's upside down. That's... I wonder if I can make some cutouts in the shell that... I mean, I guess this is going back to how much do I want this to look like a face. Does it get googly eyes? Does it get LEDs? Does it get LEDs in the shape of a googly eyes? I don't know. I think I also want this area to be enclosed. I want to avoid just having just big gaping holes in the enclosure, you know? And this, I originally opened this up because this was in the way, but I think I should have just made a more focused cutout for that. I think that was a mistake. So that's also something I should change. I mean, it's possible some of this is easier to do after the shell, but I think stuff like that is easier to do before the shell operation. I'm also not sure if it actually ended up being worthwhile to use the patch workspace, since it looked like I was having exactly the same geometry problems either way. I don't know if it was actually easier to use patch and kind of do it in several steps versus one. Oh. That's also a problem. I guess that shouldn't have been part of the model. Okay. That's right. That's fine. I think this area, this little corner can stay, but more of this will be there, and this should be mostly gone. So maybe that is the kind of stuff that's easier to do in the patch workspace. Because I did get to cut this face, whereas I wouldn't have otherwise. All right, well, more of that tomorrow. Let's get this exported. Everything is so fast in this program. Oh, nice racing stripe eyes that fade in waves when it's winching outer end. Yeah, no, that sounds great. If I can, I don't know how to make something that is visually both an eye and a racing stripe, but I like that idea for sure. And I'll think about it, because that seems like the direction to go in for sure. And yeah, the LEDs, it seems like building the LEDs into the shell is the right way to do it, because then, maybe there's a connector where the shell plugs into the microcontroller, and that's how that works. But having the LEDs on the shell seems like the way to do that. Yeah, and there's a lot. Oh, Well, I was going to say there's a lot we could do with LEDs. One limitation is that I didn't plan on including a separate DC-DC converter for the LEDs, but I guess I could pretty easily add one. So if we take off the shell for a moment, here's the single DC converter. And it's just soldered onto the motor driver board. And because of that, it would be pretty easy to just add a second one next to this, maybe? I don't know. But, like, unless we're going nuts with the LEDs, then I think we've got enough extra current on this, because I think this is good to 2 amps, and I think the MCU normal operation is maybe 150 milliamps. So that's plenty for lighting. I don't want these to be super bright anyway. Hey Tuco, do you want to hang out? I think I'm going to refresh my tea and hang out with the cat. Hope everyone else has a wonderful evening tonight. Just laughing at Whisperfist's comment. Brain the size of a planet, and they ask me to winch around a cat following camera. Ah, yes. Oh, there's a... Oh, I'm forgetting the person's name, but... Oh no, that was an accident. I just saved it, so let's not save the thing that I made an inadvertent move in. Oh, this is somebody I follow on YouTube. So maybe I can find this. Thanks, Autodesk. Maybe it's easier to find just searching for it. Oh yeah, Nick Page. That's him. I recommend these. If you're into Hitchhiker's Guide to the Galaxy at all, this guy has done some good animations. He's also got a Patreon. I recommend him. I don't recommend crashes, but they happen. All right, I think that's everything for tonight. Happy hacking. I'll see you all next time. Oh, can I get a little bit of cat on camera? He was right there. Just have to have a little bit of cat before we go. All right, have a good night, everyone. Meow.